Now, let's talk about how to actually solve linear approximation problems. I am going to give you a simple step-by-step process that you can follow every time. Step 1. Define your variables. First, identify your function. F of x is the given function. A is the given x value. Step 2, we compute. To find f of a, we plug a into the function. To find f prime of a, we need to take the derivative, then plug in a. Step 3, write the linearization. Now, we use the formula L of x equals f of a plus f prime of a times x minus a. Step 4, plug the value you want into the equation L of x. Now, let's see how this works in an example. We're given f of x equals cube root of x at the point x equals 8. And we want to approximate cube root of 8.1. Let's pause for a second. Why don't we just compute cube root of 8.1 directly? Well, that's not a nice number. It's not something we can easily do by hand. But we can compute values near numbers we already know. For example, cube root of 8 is exactly 2. So instead of working directly with 8.1, we use information at 8, something simple, and use a line to estimate nearby values. So here's the idea. We replace a complicated function with a simple line and use that line to get a quick estimate. Now, let's go step by step. Step 1, define variables. F of x is the original function, which is cube root of x. A is the given x value, which is 8. Step 2, first we need to compute f of a, which is f of 8. We'll replace x with 8 and cube root of 8 is 2. Next, we need to find f prime of x in order to compute f prime of a. To find f prime of x, I need to rewrite cube root of x as x to the 1/3. From here, I use the power rule to find the derivative. I take 1/3, bring it down to the front, and subtract 1 from the exponent. And 1/3 minus 1 is negative 2/3. F prime of x equals 1/3 times x to the negative 2/3, which is 1 over 3 times x to the 2/3. Next, I need to find f prime of a. Since a equals 8, so I need to find f prime of 8. And I replace x with 8. So I have f prime of 8 equals 1 over 3 times 8 to the 2/3. 8 to the 2/3 is 4, and 4 times 3 is 12. So I have 1 over 12. Step 3, write the linearization. L of x equals f of a plus f prime of a times x minus a. And my a is 8, so I have f of 8 plus f prime of 8 times x minus 8. Now, I replace f of 8 with 2 and replace f prime of 8 with 1 over 12. So L of x equals 2 plus 1 over 12 times x minus 8. Now, let's look at the graph on the right. The red curve is the graph of the original function, which is cube root of x. The blue line is the linear approximation, which is L of x. At x equals 8, the line touches the curve. And near that point, the line and the curve are very close. So instead of using the curve, we use the line to estimate the value around 8. But notice, as we move away from 8, the line and the curve start to separate. So the approximation becomes less accurate. That's why we only trust this method near the point. Now, let's use L of x to approximate cube root of 8.1. We will replace x with 8.1. So I have L of 8.1 equals 2 plus 1 over 12 times 8.1 minus 8. And 8.1 minus 8 is 0.1. And 2 plus 1 over 12 times 0.1 is 2.008333333. The question asked me to round to 5 decimal places. So I have 2.00833. So cube root of 8.1 is approximately 2.00833. Now, let's check with a calculator. If I use the calculator to find cube root of 8.1 directly, I get 2.00829,885. And if I round this to 5 decimal places, I get 2.00830. So the approximation is 2.00833. The actual value from the calculator is 2.00830. They are extremely close. So this method works really well when we stay close to the point.